Hello friends, I am Deepak Jain from Skill on Tech. In this video, I will explain you about how mineral deposits are explored, profiled, and raw material identification is done. I have tried to make this presentation generalized for exploration of different minerals. To understand how deposits are made, we need to know some basic principles of geology. So first, we have law of superposition. According to it, in a stratified sequence, as we can see in the figure left, there are various strata layers in the mountain and they are exposed due to erosion over millions of years. So, according to law of superposition, older strata is always below the younger one. Here we can see in the right that various stratas are also aligned after careful analysis, and it can be verified that the younger rocks are always above the older rocks. Next we have principle of original horizontality. It states that deposits of sediments occur in horizontal beds. Then we have principle of lateral continuity. It states that layers of sediments initially extend laterally in all directions. We can see example of both the principles in this figure here. Layers are horizontal, and even though deposits in between are eroded, lateral continuity can be very easily seen. Now you may be wondering that these principles are so simple, then why the geology around us is so complex? The reason is there are many geological phenomena like sedimentation, erosion, folding, tilting, plutonic intrusion, which all make it very complex. Now, what are these phenomena? Sedimentation. Here it can be seen that sedimentation in Amazon River has a huge impact in the downstream deposits over the river course. Sedimentation occurs because when river is in higher altitudes, it has high speed, and due to that, a lot of erosion takes place. During hundreds of kilometers of its course, river reaches the plains and its velocity becomes down, and heavy deposits they lay down on the riverbed, causing sedimentation. Then once these deposits are too much, then river has to change its course to flow very smoothly. So that's how sediments are formed. Erosion. As all of you know, erosion can cut out huge canyons or gorges in mountains, valleys, and plains. Here you can see example of erosion in Gandikota Canyon in Andhra Pradesh. Folding. Folding, many of you may not be very familiar. It is due to tectonic movements in the earth. So when there are ductile deposits, they can fold over and they can form complex shapes. So here you can see that we can see there is continuity over this red line, which explains that there has been folding in this particular way. Tilting. Tilting is also due to tectonic activities. Due to tilting, most of the horizontal rocks they can shift to an angle. This you can have noticed in many of the mountains around you. So here in this particular figure, you can see that tilting can be very easily seen by marked angles or strikes. Faulting. Faulting is also due to tectonic activities where there is slippage or relative movement of adjacent rocks in a single layer. So figure here you can see very easily that there has been faulting like this, where there is relative slippage in the layers adjacent to each other. Plutonic or volcanic intrusion can happen when magma penetrates the existing rocks, crystallizes and solidifies underground in an existing deposit. So here in the figure you can see that a very clear intrusion is visible in the rock here. So these are phenomena which make a source very complex. So this is a typical sketch of how a particular deposit looks like after millions of years. So many of these phenomena explained in previous slides, they can be seen here. So you can see that there has been intrusion, then there has been erosion, then after that there has been tilting, after tilting there has been fault, after this fault there has been further sedimentation, and after all this then an intrusion has been happened, so which has made this deposit look very complex. So it can happen during millions of years, and as more years pass it will become further more complex. So this is how deposits are made. So when deposits are so complex, it is very important to know them, how they are existing. So to understand the deposits, core drilling exercises are done up to several kilometers of depth in some cases, using varying drills depending on the deposit nature. So drill holes and core sampling is done at the sample intervals approximately 2 meters from each other. So core samples which are cut are collected in sequence in properly marked sample boxes and safely put. Then these core samples, they are taken to lab and arranged in horizontal sections to identify textural figures over the length of cores. When needed, thin slices of cores are also cut, polished and studied to study mineral granulometry. Once observations are recorded, these samples are cut in sections, crushed and homogenized. They are then sent for further sample analysis into the lab. Once results are obtained, 3D maps of deposits are prepared using very advanced softwares, and they are handed to mine planning department for further actions. So here in this figure you can see that as per the silica content percentage, mine mapping is done. So this can also be extended to lime percentage and various other minerals. Let us take an example of a hypothetical mine deposit. We have 3 drill hole data and we have plotted it in 2D. Data in between is not available because drilling is very costly and we cannot drill holes every few centimeters. So every few meters we have taken drills, then we have taken out the samples and we have identified and marked that these are my sandstone, limestone and shale deposits. But we don't know what is in between. So as an engineer, what you will think? As an engineer, we think, okay, let's put a straight line and this is how my deposit should look like. But Earth is not engineering. There are various possible correlations. So it can have normal faulting, it can have folded stone, it can have a thrusted limestone, it can also be isolated blocks, and there can be other several possibilities which we don't know. Actually, there are unlimited possibilities because there are so many uncertainties. So to reach towards a possible solution, surface analysis is done. So after surface analysis, results are mapped and all the visible features like strike, fault lines, they are identified and marked in the map along with the analysis. So once all of them are marked, we can see that there is very clear picture of what has been happened to our deposits. So in this particular case, we can see that there has been thrusted folding and there is also some erosion in top layer. So this is how a typical mine deposit is calculated and mine reserves and mining plans are made. So in this presentation I have given you a brief about how geologists work and how they evaluate our reserves. So to conclude this presentation, good geological mapping is decisive for evaluation of a deposit. The stratigraphic and tectonic concepts are vital to understanding 3D shape of deposit. The design of drilling grids should be based on sound geological concepts. The block model cannot be computed before having carried out detailed geological investigations. And after all these things can deposit be exploited. Otherwise, we can have a lot of monetary waste because mine planning takes a lot of money and time. So thank you all. That's all for this video. If you like it, please hit the like button below and share it with your friends and colleagues. Please leave your questions and comments and feedback in the section below. Thanks.